Hello everyone, and welcome to Multivariate Data Analysis. I'm excited to be here with you this quarter. I think this is the first quarter of, or the second quarter of your sequence, but the first quarter where we really get to dig into how we can make decisions with data. And so everything we do is going to be about evaluating the value of the data we have to making the decisions we want. That makes this an exciting time to join you in your data analytic journey, and I hope a fun quarter for all of you as we use the tools that you built last quarter to hopefully drive better decision making. So, data analysis, that's part of the name of this course, has been around for a long time. And at its simplest, data analytics, I think, is really just about data analysis. But what has people so excited is that I think there's been a revolution both in our ability to sort of employ techniques to do data analysis and to process large and interesting data sets to help us transform that simple data analysis into something that we can hopefully enhance productivity and improve decision making. It's these latter two pieces, the enhanced productivity and the better decision making, that I think are giving everybody so much excitement over data analytics. It's why, why you're taking the time out, I think, to probably join us on this certificate program, is because there's all of this potential. And I think that lots of people finally have at their fingertips a lot of the tools to begin to exploit this potential. There's also a lot of downsides, and we're going to talk about those as well. But we're going to build up our toolkit to make it possible, I think, to overcome many of these things and do good work with data. A big part of doing data analytics is taking the pieces and putting them together. And so while you've been learning tools, probably should have added that as a separate piece itself, we also are going to take the three sort of core pieces and put them together in this course and over the next 3 quarters. We're going to take a look at data. We're going to manage our data. We're going to clean our data. We're going to evaluate the quality of our data for answering the questions we want and just in general. We're going to build on that understanding of our data and your ability to describe your data with statistics. And then we're going to talk about the range of models and modeling approaches we can use to answer various kinds of questions. So, at the core of data analytics is this ever-growing process by which we ask better questions and hopefully get more detailed answers. So often one of the frustrations of data analytics is that we start down a path and we find out we don't have everything we need to make the kinds of decisions we want. Or we have the ability to narrow down sort of some of what we want or change the kinds of questions that we're asking. It's not always a direct path to the clear answers that we hope we get. And fundamentally, we need to learn to do better sort of foundational work, right? Build better data sets, gather the right data in order to make better decisions from our data. And we're going to focus on some of these issues as well. So why do it? So I think that especially as sort of public servants, we have a kind of obligation to take a look at the impact of policy changes, both the policies that we can affect and the policies that affect us that we don't have much control over. We want to take a look and understand how all of these kinds of things impact the work we do and the kinds of things that we can achieve. It also can help us that in a world of limited resources, we want to improve, where we focus our resources to improve outcomes. So connecting resources to what they achieve is an important part of what we want to be able to do. Whether it be how we're able to spend it or what we're spending it on, we want to understand and map, the resource allocation decisions we make and what that means for how we're achieving our goals. Finally, we need to plan for the future. So what we do with our resources moving forward is an important thing to do and to plan for. And having better data analytics skills can help us do a better job of this as well. So I'm a bit skeptical about whether data-driven decisions matter. I know I shouldn't admit this in this intro video when I'm supposed to tell you rah data analytics. But, you know, I'll give you my healthy dose of skepticism. I think a lot of people want to make data-driven decisions. And a lot of data-driven decisions are going to be bad decisions because they're backed by bad data or bad analysis or, God forbid, both. So we'd like to use data-driven decisions to derive new insights, to understand how things work better. And because there's this potential, right, to improve what we're already doing with even slight tweaks. We'll get to that in a second. And there's some evidence out there. It's fairly limited, but there's some evidence out there. There's lots of people claiming, oh, you'll make better decisions with data. Oh, if you take our $10,000 program or our $30,000 program or our $100 million program, you'll make better decisions with data. And maybe it's true. And there's some evidence to suggest it is true, and that using data to derive new insights is a key way in which data is helping drive better decisions, so that some data-driven decisions really are better decisions. Also, that some things like some ways of approaching data can help us make slight improvements. And it turns out that even slight improvements can matter when things are repeated frequently. So things like better cost estimates using non-parametric models, well, maybe it could matter because even if it's only slightly better, we make a lot of them, and it's slightly better on a grand scale. And so both of those things can make data-driven decisions, and making good data-driven decisions an important part of how we should approach the world in policy making and resource allocation. So I'd like to remind you of where you've been and all of the work you've done. I'd like to sort of applaud you. I'm impressed. The core of what you've done was building a toolkit, right? You built your foundational toolkit, your understanding of probability, your understanding of computer programming. Now, you think you learned R, but what you actually learned was computer programming and R. But you've learned to be better at taking something, right, that was hard and using it and sort of bending it to your will. So hopefully you feel empowered to bend anything computer-oriented to your will, using that computer programming to enable analytics. You've thought about appropriate summary statistics, how to compute them, and how to explain the results observed. The next few videos are about reviewing that and talking about those. You've used the laws of probability to calculate the likelihood of certain events, including conditional probabilities. So, right, a bit of math behind what you've done. We're going to take that and apply it to different ways of describing relationships moving forward. And you've taken a look at the basics of probability distributions. We're going to build on that to build up our statistical understanding of what data is really saying and what it really isn't saying. In this course, we're going to take your ability to describe what's going on and put it through, right, its statistical tests. You're going to demonstrate how to formulate testable hypotheses and identify appropriate empirical techniques to examine the hypotheses in question. So we're not just going to take data and summarize it. We're going to take those summaries and think about what is it we really want to know and how can we know it. And we're going to at least dive into some of the simpler models and methods to, right, come to conclusions from data. We're also going to be careful with our data. We're going to be able to identify sources of variability in data and errors in inference and how they affect that inference. So how they affect that coming to conclusions for data, and how sample data can and should be used to make inferences about a larger population and how it shouldn't. Then there's the fun stuff. You're going to be able to formulate and interpret basic models for regression and classification and understand the limits and corrections to these models. So we're going to take a look at linear and nonlinear models to a certain extent, some of the basic models. I once had an advisor who used to tell me that no matter how complex a model you think you need, you should always start with the basic ones and then make comparisons to those. So we're going to produce that fundamental and very important baseline in this course that you will use, I hope, I expect, throughout your data analytic careers, of being able to produce some fairly straightforward models and think about where the straightforward models fail you to provide the answers that you might want, so that we can move on into quarters 3 and 4, where we can look at some more sophisticated models. Finally, I hope you're able to critically and effectively interpret and evaluate data and statistics in professional and personal contexts. As I said, there's lots of people out there misusing data analytics to draw the wrong conclusions, right? We want to draw the conclusions we want to draw. Perhaps after this course you'll be better at lying with data, but I hope you'll also be better at knowing when others are lying to you with data. So how we're going to do it in this course, we're going to make choices about models. We're going to basically focus on choosing the right kinds of models for the right kinds of questions. We're also going to take some time to try to understand the data we have, consider its limitations, and the challenge it poses in answering particular types of questions. There's lots of things we'd like to know. There's lots of ways we'd like the data to inform those decisions. We should understand the ramifications of making decisions from data we have, and what kind of data we can gather, and what kinds of decisions we'd ultimately be able to make. It's tricky, and hopefully we're going to make some sense out of making sense with data. I like to start with this question. Are we paying vendors on time? And I like to start with it because it sounds like a fairly straightforward question, and it was given to me as something that's supposed to be a data-driven question. And yet, I think it's a tough question to say, is it a data-driven question? Because, well, okay, if the answer is yes, always, fine, data-driven question, move on. No, never. Okay, fine, data-driven question, we can answer that with the data. But other than that, other than yes, always, no, never, the other answer is sometimes. Those are the three direct answers to that question. And I bet it's almost always sometimes, and nobody's satisfied with the answer sometimes. They want more specifics. Really what they want to know is maybe how long do average payments take? How long do the longest payments take? Does it take longer to pay some kinds of vendors than others? Does it take longer to pay some kinds of bills than others? This course is about refining those questions so that we can answer the right questions and get at the core of what's going on that drive the patterns and issues that we want to address and improve. So we need some statistics to do it. So sadly, or happily, or, well, I like statistics, so happily for me, sadly for you, maybe you'll like statistics after this course, that's part of my goal, is we need statistics to do this. And statistics is about measuring variation and finding patterns. So it's about being able to understand what those patterns really are. And with statistics, we're able to describe data, but more importantly for this class, we're able to make comparisons and spot variation and draw conclusions from data. That's largely what we're going to be doing in this multivariate analysis class. We're going to use those probability distributions that you took a look at last class to form hypotheses and to better understand the behavior of our data. Everybody's brains jump straight to correlation. We all want to understand the drivers behind the patterns. So we want to know if there's a pattern worth understanding, right? Why waste analytical dollars, right? Why waste analytical time and effort on things that aren't really things? Once we think we have a thing, right, to understand, we want to understand what some of the drivers are, what's related to the pattern that we observe. And a big part of what we can do when we have statistics is we can debunk a lot of scoundrels who draw bad conclusions from data analysis. So to think back to that initial questions, how long do average payments take? How long do the longest payments take? These are descriptive questions that we can use the kinds of descriptive statistics you've been doing to answer. But moving on from here, we might want to do some inference. How frequently would we expect payments to be late by X days, right? We're trying to predict or understand a relationship. Are some organizations paying their vendors later than others, right? Another kind of relationship between the data, another kind of pattern we want to see if it exists. Moreover, we might want to understand correlation. Are payments later at different times of the year? Are there other factors that drive late payments, right? This is where your brain is going, and good for you because this is where we're going in this class. This is what we can do with statistics. So at its core, this class is about the fundamentals of these things, understanding patterns and drivers of patterns and how to model them. From here, we have 2 more quarters together. I hope you're excited about that. I'm excited about that. And that's going to give us an opportunity to tackle more models and spend some time managing the kind of data we have and doing things with that. So included in more models are more sophisticated and precise data visualizations, trying to communicate the results of various kinds of models to people, and building appropriate models for appropriate circumstances. So that's going to take a fair amount of our time. There's been a revolution in, I think, especially for predictive purposes, model building, and the ability of your average everyday user to pull up an instance of R or Python or Stata or something like that and produce a fairly sophisticated model for analysis. So we're going to tackle our piece of that data revolution in our future courses. But we're going to start with the simple things, right? Know the rules before you break them in this course. Also, we're going to spend some time on the data itself. There's been a revolution in data gathering and dissemination. When I started at the Department of Defense, people were surprised that people would take data sets from various sources and put them together to derive meaning and interesting, sometimes challenging results. That's become commonplace. But to do it well, we need to have at our disposal some tools. We're going to look at the Jupyter Enclave in Advana to look at managing Navy financial management data and how we can use that kind of data to derive important insights. So that requires some data management itself, which we're going to do later in the next 3 quarters. So with that, I hope you're excited to tackle model building with me, and because I'm excited to tackle it with you. We're going to do some reviewing of some basic descriptive statistics next. You're also going to review some of the rules of probability in class. And from there, we will jump into using those probability distributions to help us understand what's going on and make better decisions about data. All right, so with that, we have lots to do. Let's get started.